Everyone, we're back for day 11. Today is a Sunday. I'm filming a little bit early today because I have a math modeling activity that I'm doing for the rest of the day. So we're back to my arch nemesis linked list. Hopefully this is the last one I do. I was doing some tree problems yesterday too. Not for the video, but just getting a hang of how those work. Yeah, so let's get started. It's January 26th, 2025, day 11 of coding every day. Today we're looking at LRU cache. Okay, so it seems to be an object-oriented problem. Least recently used cache class LRU cache. Least recently used. Okay, so like the oldest used. So initialize the. Okay, so capacity equals capacity. Done. Get the value corresponding to the key if the key exists, otherwise return -1. Okay. Update the value of key if the key exists, otherwise add the key value pair to the cache. If the introduction of the new pair causes the cache to exceed its capacity, remove the least recently used key. The key is considered used if a get or put option is called on it. Ensure that get and put each run on an average O of 1. So O of 1, overall space of O of n. So I'm obviously thinking, key value pairs, so we should probably have a hash table. And then in terms of capacity, okay, so let's look at an example here. So 2, that's the capacity, right? Okay, so capacity is 2. So capacity equals 2. That might be current cap equals 2. All right, put 110. So cache of 1 equals 10. So I'll just put 110. Get 1. So that returns 10. So it returns the value at the key, okay? Put 220. So now the cache is 110, 220. Put 330. Okay, so this kind of reminds me of first in, first out. So I could use a queue. Okay, so I'm gonna say self.d is a new dictionary, and self.q is from collections imports deck. Q equals a deck, which will be empty. Okay, so puts. So we're gonna say self.d. Okay, first of all, if key not in self.d, return -1. And then otherwise, return self.d of key. Right? So if it's not in the dictionary, return -1. Otherwise, return the key. Okay. And every time we put something, oh, I see. Wait, actually, this is get. We don't. This is the get function, actually. Okay, so that's simple. I don't think the get function really requires any other functionality, and that this runs in O of 1 as well. Okay, so for puts, so I would say self.q dot append, or I guess append left key. If length of self dot q is greater than capacity, then self dot q, wait, so I'm thinking if we want to append, I mean, I don't think it matters, but what side are we going to pop from? Because if we're popping from, I think we want to pop from the right side. So the newest will be at the left. So it'll be like new, old. So we'll add things here. And then so the oldest one will be here. Okay, so self.q pop. So that keeps it in capacity. Okay, and then so that takes care of the queue. So we have to make sure that we also remove so removed key. I guess we could do it as key value pairs. And then can we say delete key value from D or something? How does that work? Maybe like that. Do the keys have to be unique? I wonder if dictionary has like a remove item or something like that. Okay, so let's assume that this works for now, which it doesn't, most likely. So get is fine, and then puts, and then we also need to put it into the dictionary. So I'll say new key. Well, just key, yeah. So these are ones getting removed. So then we want to add it to the dictionary. So we would say self.d of key. Oh, well, I guess I'm kind of stupid. Well, maybe I'm not stupid, but I forgot something. So dictionaries have to have unique keys. So we don't have to do this. What if... So my question is, what if you put the same key twice? Is it supposed to override it? Okay, update the value of key if the key exists. Okay. So that makes it a lot more simple. So I think we can say... So this is a key, right? Yeah. So we'll keep the thing of keys, a queue of keys. And then, so this will return a key. So then we'll say D... I honestly don't remember how to remove from a dictionary. I think it's delete. Like that. So this must exist in the dictionary because we've added it before. So we'll say self.key equals value. Okay, so we add it to the queue and we add it to the dictionary. Is this O of n space? Yeah. It's just 2n. Okay, so when we put it, we append left the key and then put it in the dictionary. And then if the length of the queue is greater than capacity, Then we remove it from the queue. We pop it from the queue and then remove that key from the dictionary. Okay, sorry, I had to seize there. Okay, let's see what happens. Oh, it's supposed to return. Okay. Okay, we have a typo here. Self.capacity. Wrong answer. D. Okay, so we passed the first test case. Okay, so it looks like this is getting us 10, which is not in it. So we put 1, 1. Okay, so let's just trace it here. So we put 1, 1. What's the capacity? 2. So cap is 2. Then we put 2, 2. Then put 3, 3. Which then deletes this. Then we put 4, 4. Which then deletes this. Okay, key error 10. So why would there ever be a 10 in there? So for this one, so if I look at the test case, I want to see what these nulls. So okay, so let's say null, null. Okay, null, null, null. 1, null, 2. So is that supposed to be -1? So that's supposed to be -1? Oh, okay. So if you call... Oh, interesting. So it's not when it was added. It's also if you get it. Then it becomes the first... I see. So when we get, we should also, I mean, what we could do is, well, get should function in O of 1. Okay. Because I was thinking we could remove it. Wherever it is. So essentially, so the gets actually do matter. So we have 1, 1, 2, 2. Now we get 1, so this goes here. And then okay, so my thinking is to remove it from, so for instance, I could say like self.q.remove key. and then say self.q.pen left key. But the problem with this is that this is O of n. So instead, I'm wondering if because the queue only functions on the queue basically tells us so maybe we could have a running counts, and then I'm thinking we could say in our dictionary we can just remove we can remove stuff by just setting it to -1. Okay, so for instance, so if we have our dictionary, and then we could just have like a count variable that goes up and down as we add stuff. Okay, so dictionary. So put 1 1. So we know our current capacity or count now equals 1, and dictionary is 1 1. Okay, then we put 2 2. Because we don't need to know what was the most recently used, we just need to know the least recently used. Okay, so our count is now 2. Get 1. Okay, so we need some indicator of which is the least recently used. So maybe when we get 1, we can add another copy of it and remove it. So 2 2 is the newest. So from now on, I'm going to say new and old. Okay, so 2 2 is the newest at this point. So because we get it, maybe what we say is, so when we get, we just are going to remove whatever's on the end, the oldest. Make it -1 in the dictionary. Sorry. Make it -1 in the dictionary. And then add the new one to the front. So that's all constant because we popped from, we pop from Q. Just pop whatever's at the end. Set the dictionary to -1, like of that key. And then add new. And I think this is the key, or like the trick. So, because we don't know, because to remove it, well, we could remove it from the dictionary too, right? So do I have it, but because can we just remove it from the dictionary? But then the Q, well, to remove it from the Q, well, okay, so we don't actually remove the key. We just pop Okay, okay. So we say if, so like this, if length of the queue is greater than capacity, then we want to pop the queue. Oh, okay, that's awkward. Okay, so self dot queue dot pop. So we're gonna remove the least frequently used and delete that from the dictionary as well. So I think that's fine. So can we just do the same thing? So remove the least frequently used and append left key. Okay. Okay, so now we got wrong for this one. Oh, only if it's in the key, or if it's in. Yeah, only if it's in the dictionary. Okay, let's trace this here. So 2 is our capacity. We put 110. Okay, so we put 110 in our queue and in the dictionary. We don't need count. So now we have 110 in there. Now we get 1. Okay. So key is in there. So length of self.q is greater than self.capacity. So that's not true. So we don't actually want 2 keys in there either. So we only want to do this if it's greater than the capacity. Okay. Okay, so now we're back to this test case. Okay, so same error as before. Okay, so put 1 put, so that goes here. Put 2 get 1. So do we add it first? I think because on the other function, we add it first. And then if it's greater than the capacity. Okay, now they're both wrong. Well, I think with this one, maybe we could say if it's greater than or equal to the capacity, then delete it. All right. All right, so my problem with this one was you add 2, and then you get 1. So getting 1. So the newest is 2. Okay, so we put 1. So now we get 1. So when we get 1, we remove the oldest from both the queue and the dictionary. So we're good with that. And then we add back. We add it back to the. Yeah, so we just get. Do we have to delete it from the dictionary? Okay, so is that the problem there? Well, key error 1. Yeah, I think that this is the problem. So we... I actually don't even know if it's triggering with key equals 1. Yeah, so for this one, I think we want to equal, so... And then it's giving me a key error, right? Yeah. Alright. So if we're getting... Well, actually... I don't even think if the get actually matters. Like, if it's greater than capacity or not. Because let's say capacity is 5. Yeah, I see the problem. So if capacity is 5, so let's say we had like 1, 2, then we had like 3, 1. So if our keys, so these are actually just keys. So if our keys were, like if this was 5, for instance, and we had 1, 2, 3, 4, 5. 5 is the oldest. And then we say get 3. This will delete the old and put 3 here. Is this supposed to be a set? But you can't. So it should all be unique. So, I mean, if we think of linked lists, so if we add like 1, 2, 3, 4. Capacity is 5. If capacity is 5. Alright, let me see if it works with the n, the O of n. So if I remove it from the queue, and then say q dot append left key. And then I think that's all I have to do really, because I don't have to change the I don't have to change the dictionary at all. Okay, so this Okay, what's wrong with this one? So it's 3. So that might be what's wrong. So put 1, put 2, put 3, get 1. So right now we have 1, 2. So it's 1, 2, 3, and then we get 1. So it should be like that. Get 2, so 2 goes here. Get 4, so 4 doesn't exist. -1. Let me see what's different. Actually, okay, this one. So get 4. 4 doesn't exist. Put 4, 4. So we remove that. Put a 4. Get 1. So 1 goes here. Get 2. 2 goes here. Get 3. 3 doesn't exist. So we're right here. Okay, so it's after the 2 nulls. So get 4. Get 2. Get 2. Put 1, 8. Okay, is that a problem? So put 1, 8. So put 1, 8. So I would do that. Oh. So I just add a 1 like here, I think. And I say 1, 8. And then pop this one. Then put 3, 7. So delete this. So we put the 3. And then delete this one. Get 1. So 1 should give me 8, right? Yeah, but I say 1's not in there. Okay, I think it had to do with putting something that's already in there. So if we're putting something that's already in there, we want to add its, maybe we could say if key in self.q. Well, that's in self.d. So if it already exists, then we want to self.q.remove key. So if it's already in there, we'll remove it and then add it to the left. Then it shouldn't be greater than capacity then, if we remove it and add it to the left. We don't really want to remove, yeah, because the key could be anywhere. So if it's like, if the queue is like this and you add a 1, so if you say like put 1, 8, normally it just deletes this one and puts a 1 here. Okay. Nice. Okay. So I got it with O of n. So I got it with O of n. So to do it, so both of my methods are, and even if you use like a priority queue or something like that, I think that's still n to push something to a priority queue like that. So now we could think about how to use a linked list. So obviously we need a dictionary, which maps. Cause this is under linked list, right? Yeah. Okay, so I'm gonna keep this O of n solution, and then in terms of how to make it O of 1, I think I may look at the hints. Okay, yeah, I'll look at the hints. Okay, so that's dictionary, the least recently used, the order of the values. So I thought Q, but maybe we can use linked list. So instead of a Q, can we have like, so if you put 1, and then you put 2, so get 1 means, oh, do you just make it like the head of the linked list whenever you use it? Get, okay, so then let's say we make it the head. Put means, so when you put something, you create a new, because this is the most recently used. So if the head is the most recently used, then we create a new node and point it to the old one. That's when we put 330. So then when the capacity gets overwritten like this, and if this is the head, it would take O of n to remove. What can capacity be? To 100. So is it like from the head you can move capacity spaces? So get, and then when you get to, you create a new node to, so every time you create a new node and point it to whatever was before. And then get 1. So 1 doesn't exist, so you ignore it. Or maybe do you have 2 pointers, like one at current and the other is like capacity? And you have like previous capacity. So every time you add something new, capacity goes to previous capacity. Well, because you can't move backwards. So maybe I have it the other way. So you have so every time you add something new, so for instance, so the head would actually be the oldest one. And then you say, so put 210. So you add a new node and then point. So if this is like the newest node, you point the newest node to the new one that you added. So then if I have 310, I point the newest one there. And then whenever we exceed capacity, we can remove this one and make head this one, which should be O of 1. Okay, what if it looks like 1, 3, 4. So this means that our oldest end capacity is 3. Actually, let's say 3, 1, 4. So we have new, and our head is here. And if we want to get 1, now that's a little tricky because you don't have access to the 1 in O of 1 time. So what we would want is, if capacity is 3, you would want it to look like this. Or maybe we can just like add it to the end or something. So we could say 3, 1, 4, 1. Like this, maybe? But then we're greater than capacity. Yeah, okay. So I think I'm going to call it there. I got it with O of n. And then maybe I'll come back to it and try to think about how I could do it with a linked list or look at the solution or something. But okay, so that was day 12. Thank you for watching. I'll see you next time.